Hi, welcome to this video on multiplying and dividing fractions. Right, I'd like you to take down these notes over here, so pause the video, get them all copied down, and then we can focus on what's happening in the maths. You might also want to copy down what you see on the board, because these are going to be our examples that we're going to be using. Right, so assuming you've done that, we're going to jump straight in. Alright, so when I'm multiplying fractions, you've got to get your head around what is actually happening. Now when I multiply normal numbers, integers, whole numbers, 4 times 4 is going to give me 16, 4 times 2 is giving me 8, 4 times 1 is giving me 4, so my numbers are getting smaller. So when I say 4 times a half, because these numbers have been getting smaller, my answers are going to be getting smaller. And what's actually happening here is I've divided this by 2 to get 2, divided that by 2 to get 1, and I've divided that by 2, and each time you notice my answer gets smaller. Now if you think of that, that's actually the same as 4 divided by 2. Okay, so when I multiply fractions together, if we think about this, when I'm multiplying fractions together, let's say I had, I don't know, 2 quarters divided by, multiplied by a half. All right? That's basically the same thing as saying half of 2 quarters. We can draw that graphically. Well, here's the chocolate bar. If I divide it into 2 quarters, I divide it into quarters, assuming they're equal, it's actually making it a little more equal. There we go. Here are my 2 chocolate bars. I'm going to my 2 parts that I've got, 1 and 2 representing my 2 quarters. If I want half of that, that's just going to be 1 there. Okay, so another way I can think about this is if I then colour in half of that, wherever they overlap, as my answer. Alright, so that's multiplying of fractions graphically. It is easier than that when we think about it mathematically. Because all we're going to be doing, the method we're going to be doing, is we're going to have a look at this and say, alright, I'm just going to multiply my numerator by my numerator, and my denominator by my denominator. Okay? Let's have a look at this. So I've got 2 times 9, that's going to give me 18, and 3 times 10 is going to give me 30. I could accept that as an answer, except I know that I can simplify it. If I look at that, I think, well, I could divide top and bottom here by 3. So if I divide 30 by 3, I end up with 10. And I know that 18 divided by 3 is going to give me 9. Sorry, 18 divided by 3 is not 9. 18 divided by 3 is going to give me 6. Again, 6 tenths. I can look at that again and go, oh, I can actually divide top and bottom through by 2. I'm going to give 3 over 5. So I can say 2/3 times 9/10 is 3/5. Right, and that's the mathematical way that we proceed when we multiply by fractions. In my opinion, it's actually a lot easier than when I add or subtract fractions. I don't need to worry about finding a common denominator first. I can just multiply straight through. Remember, that is for multiplication only. All right? That's when I multiply straight through. You can't do it for subtraction or for adding of fractions. There is a little shortcut, and it's what's called cross-cancelling. And the reason for this, the reason we can do this is because if I were to multiply this large fraction, I'd actually have 1 times 4 times 10 over 2 times 5 times 12. Doesn't matter what those numbers are, that's what the numbers are going to be made up by. And then I would find the answer, and then I'd try to find common factors and divide through top and bottom by those. I could make this easier and just look at that and think, well, why don't I divide through by common factors now? They're all multiplying, so it doesn't matter whether I divide now or divide later, because I'm still going to get the same answer. Alright, so if I divide top and bottom by 5, 5 divided by 5 is 1, 10 divided by 5 is 2. Right. Let's divide top and bottom by 4 now. 4 divided by 4 is 1, 12 divided by 4 is 3. I've got a 2 up here now, so I can go 2 divided by 2, that's going to be 1, and 2 divided by 2 is 1. Now what I actually have, if I rewrite this, I've actually got 1 times 2 over 1 times 3, which is 2/3. If I'd done this the long way, I could have gone 1 times 4 times 10, and that would have given me, if I put that in green, would give me 40, and 2 times 5 is 10, 10 times 12 is 120, and if we simplify that down, that's going to give me 4 over 12, which will eventually give me 2/3. Right? So it does work the same. My key here, if I want to cross cancel, it will speed me up, but I must multiply, I must divide through anything on the top by anything on the bottom, and I must ensure that I'm only multiplying at the top. All right, so I can't have an addition somewhere in there. It doesn't work with addition. All right, so that is multiplying of fractions. We just multiply numerator by numerator and denominator by the denominator. Okay, if you want to cross cancel, you can, but if you don't want to, if you haven't really got it, that's okay. You can simplify at the end. You're essentially doing the same thing. Okay, before we get on to the division of fractions, or dividing the fractions, something I need us to think about. What does this sum actually mean? I have 6 divided by 2. What it means is, how many groups of 2 can I get from 6? Well, clearly, 3. Okay, that's what that actually means. So what then if I had 6 divided by a half? If we go on the previous logic, 6 divided by 2 means how many 2's go into 6. So 6 divided by half is how many halves go into 6. Well, if I had 1 divided by half, that's easy, that's 2, because there are 2 halves in 1. So I don't have 1, I've got 6. That means I must have 12 halves, because I've got 2 halves in 1, and I've got 6 ones, so 2 times 6 gives me 12. What about 6 times 2 though? That's going to give me 12 as well. Okay, let's try something else. Let's do, I don't know, 2 divided by 1/3. How many thirds are there in 2? Well, there are 3 thirds in 1, so that means there must be 6 thirds in 2. 2 times 3 is equal to 6. And if I do something like this, if I, instead of writing 3, instead of writing 2, I do 2 over 1 and 3 over 1, I find something that's actually quite interesting. My division sum has changed, my division operation here has changed to a times operation. And that's changed in both of them. And all I've done with this, what was 1 over 2 is suddenly 2 over 1. What was 1 over 3 has suddenly become 3 over 1. So from that I can get the general rule of stay, change, flip. Right? So this first one, the first number stays, the second number changes, and the third number flips. Mathematically, what that's actually saying is that dividing by a fraction is the same as multiplying by its inverse. Dividing by a fraction is the same as multiplying by its inverse. When I invert a fraction, I'm flipping it over. So 1 over 2 is the inverse of 2 over 1, and 2 over 1 is the inverse of 1 over 2. Alright, so that's where the rule that I'm about to use comes from. Alright, so I'll leave that up there. Let's have a look at this. So bearing that in mind, I've got 2 over 3 divided by 4 over 9, so that's 2 over 3. That stays, that changes, and then I flip. 9 over 4. And then I can multiply through by normal. So I can go, if I do, I've got 2 methods we're going to use here. I can do 2 times 9, that gives me 18. 3 times 4, 3, 6, 12. Okay, I've got 18 over 12. That's alright, that's 9 over 6, which is, let's put this equal signs, 9 over 6, which is 3 over 2. And if I do top divided by bottom, it gives me 1, remainder 1 over 2. They're 1.5. If I wanted to cross cancel, which is my second method here that I'm going to use, 2 into 2 goes once, 2 into 4 goes twice, 3 into 3 goes once, 3 into 9 goes 3 times, so I end up with 3 over 2, and from there I can go 3 divided by 2 gives me 1, remainder 1 over 2. Alright, as you can see, obviously I've done quite a bit of working, actually done on purpose here, so you can see how much faster it is when we cross cancel. Okay, so that's division with fractions. The key there is you've got to remember stay, change, flip. You've got to apply it all. this number stays, that operation changes, and my fraction flips. By the way, if I get, if I'm asked to divide with mixed numbers, please make sure you convert to improper fractions first, okay? Even if I'm dividing, multiplying, adding, or subtracting with numbers, I always try and convert to improper fractions first. It makes my life easier, all right? Might be a little bit of work at the beginning, but overall you're far more likely to get the correct answer, and that's what we're aiming for. All right, so let's have a look at some questions you want to do at home. There we go. If you'd like to pause that, have a go, and I'll go through some of the answers now. Okay, so assuming you've done that, here we've got the answer for my multiplication one. As you can see at the top there, I just went 1 times 2 and 7 times 3. Over here, I got 6 over 20, and then that's just telling me what I divided top and bottom by. For this one, I did two methods, one with the cross-cancelling and one without it. As you can see, I got 2 over 5 for both answers. It just involved me simplifying a bit there. If you want to have a look here, 3 went into 3 once, 3 went into 3 once, 4 went into 4 once, and 4 went into 4 once there. So if I rewrite that there, I just go 2 times 1 times 1, and 1 times 1 times 5, 2 over 5. Okay, so that's my multiplying. Division. Okay, first one, 1/3 divided by a half, stay, change, flip, I get 2/3. And then I've got 3/5 divided by 4/5, stay, change, flip. I could have cross-cancelled here. 5 into 5 goes once, 5 into 5 goes once, end up with 3/4. I didn't, but you could have done that if you wanted. Over here I did do some cross-cancelling, so I didn't have to worry about such large numbers. I end up with 14 over 30. Even though I cross-cancelled though, I still have to check whether I can simplify, because at this point I can definitely simplify down to 7 over 15. And you always want your answer in the simplest form. Alright, hope that helps. Hope you are a little bit more comfortable with multiplying and dividing by fractions. If you want some extra work or to have a look at some, extend yourself, perhaps have a look at algebraic fractions, or if you want to revise, go back and have a look at equivalent fractions, or perhaps adding and subtracting fractions. Alright, that's it from me. I'll see you next time. Cheers.